Welcome dear learners. In this video lecture, we are going to continue with the topic of mathematical expectation and variance, but this time it is for joint distribution. In the earlier video, we have discussed the same concept for the single random variable, and now through this lecture, you will be able to understand the concept of expectation and variance for two random variables, and you will be able to find the covariance and coefficient of correlation between the two random variables. First we will see the mathematical expectation, expected value or the mean for the two random variables. Suppose x and y be the two random variables and f of xy be the joint probability function. Then the mathematical expectation of the random variable x and y is given by expectation of x, which is denoted by mu x, and expectation of y, which is denoted by mu y. If the random variables are discrete, then mu x is equal to double summation over x and y, x into f of xy, and expectation of y, that is mu y, is equal to double summation over x and y, y into f of xy. If x and y are continuous random variables, then mu x is equal to double integration over x and y from minus infinity to infinity x into f of xy dx dy, and similarly mu y, that is expectation of y, double integration from minus infinity to infinity y into f of xy dx dy. Variance. The variance of random variable x and y is denoted and defined as, for discrete random variable, it is denoted by sigma square x, that is variance for x, which is equal to expectation of x minus mu x whole square. Here mu x is the expected value of x, that is the mean of x, and which is equal to double summation over x and y, x minus mu x whole square f of xy, and sigma square y, that is variance of y, is expectation of x minus mu y whole square. Mu y is expected value of y or the expectation of y, which is equal to double summation y minus mu y whole square into f of xy. For continuous random variable, this summation will get replaced by double integration from minus infinity to infinity. So variance for x is double integration from minus infinity to infinity x minus mu x whole square into f of xy dx dy, and variance of y is equal to double integration from minus infinity to infinity y minus mu y whole square f of xy into dx dy. Standard deviation is nothing but the positive square root of the variance, and standard deviation for x is equal to positive square root of variance of x, and standard deviation for y is equal to positive square root of variance of y. Now the covariance of x and y. So for the covariance for discrete random variable is denoted by sigma xy is equal to covariance of xy, which is equal to expectation of x minus mu x into y minus mu y. If it is discrete random variable, then double summation x minus mu x into y minus mu y into f of xy, and if the random variable are continuous, then sigma xy, that is covariance of xy, is equal to double integration from minus infinity to infinity x minus mu x into y minus mu y f of xy dx dy. The coefficient of correlation of x and y, it is the measure that how these two random variables are correlated. It is the degree of correlation, we can say that. So it is denoted by rho, which is equal to sigma xy upon sigma x into sigma y, that is covariance of xy upon standard deviation of x into standard deviation of y. Now here we have some important results, that sigma xy or the covariance of xy, it is equal to expectation of xy minus expectation of x into expectation of y, and this result we obtained from the definition of covariance of xy, that is expectation of x minus mu x into y minus mu y. If you solve that, you will get this result. Then variance of x plus minus y is equal to variance of x plus variance of y plus minus 2 times covariance of xy. Next is, if x and y are independent, then covariance of xy is equal to 0. And if the covariance of xy is equal to 0, then the coefficient of correlation, that is equal to rho, is also 0. Expectation of xy is equal to expectation of x into expectation of y. If we substitute covariance of xy is equal to 0 in first point, we will get this result, that expectation of xy is equal to expectation of x into expectation of y, and variance of x plus minus y is equal to variance of x plus variance of y, as this covariance of xy is 0. So point number 2 will give us this result if covariance of xy is 0. Now we will see some examples of joint expectation for the discrete random variable. The joint probability function of two discrete random variable x and y is given by f of xy, which is equal to c times 2x plus y for the interval 0 less than x less than 2 and 0 less than equal to y less than or equal to 3, and it is 0 otherwise. We have to find out expectation of x, expectation of y, variance of x, variance of y, covariance of xy, and coefficient of correlation. So as this is the example of two discrete random variable, we have to proceed with the joint distribution table. So given joint probability distribution f of xy is equal to this. The joint distribution table is given by x is taking the value 0, 1 and 2. X is taking here discrete value. X and y both are taking the discrete value 0, 1, 2, and y is taking 0, 1, 2 and 3. When we will substitute x0 and y0 in this function, we get probability distribution as 0. When x0, y1 we get c, and likewise go on substituting the corresponding values of x and y, we get the probability distribution for that values. Now this total probability is 0 plus c plus 2c plus 3c, then 2c plus 3c plus 4c plus 5c. So all this sum is equal to grand total, and that we have to write it here. But before that, we will check the marginal probability function for x, which is denoted by f1x. For x equal to 0, we have to take the horizontal sum of all the probabilities for x equal to 0, which is 6c. In this case, for x equal to 1, it is 14c, and for x equal to 2, it is 22c. So these are the marginal probability function for different values of x, and similarly marginal probability function of y, which is denoted by f2y. For y equal to 0, it is 6c, for y equal to 1, it is 9c, for y equal to 2, it is 12c, and for y equal to 3, it is 7 plus 5 plus 3, that is 15c. And if we take the summation of all these probabilities as well as summation of f1x and summation of f2y, all these three are same, and which is equal to 42c. Now from this grand total, we are going to find out the value of this c, which is given as grand total, that is double summation over x and y f of xy, that is sum of the all joint probability t's is equal to 1, that is 42c is equal to 1, that means c is equal to 1 by 42. So replace c by 1 by 42 in the joint probability function, you will get f of xy like this. Now we have to find out the expectation of x, which is given by the formula mu x is equal to double summation over x and y, x f of xy. Now take this summation y inside the bracket over f of xy and substitute the different values of x. When we will substitute x equal to 0, sum of all the probabilities for x equal to 0 is 6c. You can see it in the table. When x is 0, sum of all probabilities, when we run the summation over y, sum of all the probability is equal to 6c. So 0 into 6c. For x equal to 1, sum of the probability is 14c, that is 1 into 14c, x into summation of f of xy. And when x is 2, summation of f of xy is 22c. So if we add this together, we get 58c, but c is 1 by 42. So answer is 29 by 21. Similarly, find out expectation of x square. Expectation of x square is equal to double summation over x and y, x square into f of xy. Again, run the summation over x first, x into x square into summation y into f of xy. So substitute the value of x and f of xy here. We get, when we have x equal to 0, so it is 0 square, and sum of all the probabilities for x equal to 0 is 6c. We have to take the square of x only. So 0 square into sum of the probabilities, that is 6c. 1 square, then sum of the probabilities for x equal to 1, 14c, and 2 square into 22c. In this way, we will get the value for expectation of x square. Now, expectation of y, in the same way, double summation over x and y into f of xy, which is equal to summation over y for y into summation over x of f of xy. So when we have y equal to 0, sum of all the probability equal to 6c. When y is 1, sum of all the probability is equal to 9c. When y is 2, if we run the summation over x, sum of all the probability is 12c, and for y equal to 3, it is 15c. If we add this all together, we get 78c, and c is equal to 1 by 42. So expectation of y is 13 by 7, and expectation of y square is 0 square into 6c, 1 square into 9c, 2 square into 12c, 3 square into 15c, which is equal to 32 by 7. Now, as we are ready with the expectation of x and expectation of y, as well as expectation of x square and expectation of y square, we can get the value of variance of x and variance of y by using the formula that variance of x is equal to expectation of x square minus expectation of x whole square, which is equal to 17 by 7 minus 29 by 21 whole square. 29 by 21 means expectation of x whole square. So it is 230 by 441, and variance of y is 55 by 49. Now covariance is equal to expectation of xy minus expectation of x into expectation of y. So we have to find out here expectation of xy, but the expectation of x and expectation of y is ready. So expectation of xy is double summation over x and y, xy into f of xy. Now one by one we have to put the values of x and y and multiply it with the corresponding probability. So when x is 0, y is 0, the probability is 0. When x is 0, y is 1, probability is c. So in this way we have to find out, or we have to take the summation for all x and y values here. So 0, 0 into probability f of xy is 0. Now 0 into 1 into its probability. So in this way I have calculated it for all the 12 values, that is 3 values for x and 4 values for y. So total 3 into 4 for 12 values we have to find out this, or for 12 values we have to run this summation, and expectation of xy is equal to 17 by 7. Now substitute this in the formula of covariance of xy. We get the value for covariance of xy as minus 20 by 147. And the coefficient of correlation, that is rho, equal to sigma xy upon sigma x into sigma y. Sigma xy means covariance of xy, and sigma x and sigma y are the standard deviation for x and y respectively. So it is minus 20 by 147. Positive square root of variance of x is square root of 230 by 441, and this is positive square root of y, that is square root of 55 by 49. Using the calculator, you can get the value of this coefficient of correlation, which is minus 0.1778. So as the sign of coefficient of correlation is negative, we can say that it has a negative correlation. Let's take another example. The joint probability function for the two discrete random variable x and y is given by f of xy is equal to xy by 36 for x equal to 1, 2, 3 and y equal to 1, 2, 3, and it is 0 otherwise. And we have to find out the same thing: expectation of x, expectation of y, variance of x, variance of y, and covariance of xy. Now prepare the joint distribution table for x and y values. When x is 1, y is 1, the probability is 1 by 36. For x1, y2, probability is 2 by 36, and likewise we have the different probabilities for different values of x and y. The marginal probability function for x is given by, for x equal to 1, it is 6 by 36, for 2, 12 by 36, and for 3, this marginal probability function is 18 by 36. Similarly, marginal probability function for y is given by 6 by 36, 12 by 36 and 18 by 36 for y equal to 1, 2, 3 respectively. And if we check the sum of f1x, which is 1, also the sum of all f2y is 1, and sum of all these probabilities also equal to 1. Now expectation of x is equal to double summation over xy into x into f of xy. When we put x equal to 1, sum of all the probability for x equal to 1 is 6 by 36. So it is 1 into 36 plus 2 into 12 by 36 plus 3 into 18 by 36. And expectation of x is 7 by 3. Similarly, expectation of x square is equal to double summation over x and y, x square into f of xy. So it is equal to 1 square into 6 by 36, 2 square into 12 by 36 plus 3 square into 18 by 36, which comes out to be 6. And expectation of y is equal to double summation over x and y into f of xy. When y is 1, probability is 6 by 36. When y is 2, sum of the probability is 12 by 36. And y is 3, sum of all the probability is 18 by 36. So it is 1 into 6 by 36 plus 2 into 12 by 36 plus 3 into 18 by 36, which is equal to 7 by 3. And expectation of y square is equal to 6. So variance of x is expectation of x square minus expectation of x whole square. So it is equal to 5 by 9. And variance of y is again 5 by 9. Now expectation of xy is equal to double summation over xy into xy into f of xy. So substitute the values of x and y and multiply it with the corresponding probability. So when x1 y1, probability is 1 by 36. When x1 y2, probability is 2 by 36. When x1 y3, probability is 3 by 36. In this way we have to calculate it for all the 9 values and take the summation of this. We will get expectation of xy is equal to 49 by 9. And then find out covariance of xy, which is equal to expectation of xy minus expectation of x into expectation of y, which is equal to 0. As expectation of xy is 49 by 9, expectation of x is 7 by 3, expectation of y is 7 by 3, and 7 by 3 into 7 by 3 is again 49 by 9. So covariance of xy is 0, and that's why the random variable x and y are uncorrelated, or we can say that the random variable x and y are independent. So this is what all about the expectation variance for the joint distribution. Thank you very much.